Welcome and good morning to all the students present in this video lecture. Today in this lecture, we are going to solve the numerical based on the static forces and the center of pressures. So let's start with the numerical number 1. A rectangular plate of 3 meter by 5 meter is immersed vertically in the water such that the 3 meter side is parallel to the surface of water. Determine the hydrostatic force and the depth of the center of pressures from the top edge. So here we have one plate, which is a rectangular plate. So let's say it is like this. So this is a 5 meter side and this is the 3 meter side. Now the orientation is given. Suppose I am taking this surface as my free surfaces. Then it is say that the 3 meter side is parallel to the water surfaces. Means the 3 meter side is this side 3 meter, which is parallel to the water surfaces, and the 5 meter side lies over here. So it is located like this. So this is the 5 meter side, which is acting as a depth, and this is a width. Determine the hydrostatic force and the depth of center pressures if the top edge of the plate is 2 meter below. Means the distance between the top edge and the free surface of the water, this distance is given, and that is the 2 meter. And student, if you remember, for the rectangular plate, the CG lies over here. So this is the center of gravity, we called as G, and that is our H cut. This is our H cut. So in this way, we have to find it out the hydrostatic forces, as well as we need to calculate the height of the center of pressure. First, we write it down the given data. So area of plate is indirectly given, that is a 3 by 5. So we get a 15 meter square. Now our IG axis, which is passing through this point, so IG is there. We have to find it out the moment of inertia about the horizontal surfaces. So perpendicular dimension is 5. So according to formula, that is a BD cube by 12 for the rectangular plate. So we get the 3 into 5 to the power 3 divided by 12. So in this way, we are able to find it out this moment of inertia, and that value of moment of inertia is 31.25. Then what we require, it is water is there. So we mentioned the density, that is 1000 kg per meter cube. And for the easy calculation, we assume that gravitational constant, that is G, and it is 10 meter per second square. So first of all, we find it out the total pressure force. Total pressure force. So total pressure force, which is denoted by F, which is equals to rho G A H. And here the H cut. So the H cut is located this total distance. So we have to find it out the H cut. So this distance from the free surface, that is the 2 meter is mentioned, and the half of this 5, that is a 2.5. So 2 plus 2, so we have the H cut equals to 2 plus 2.5 meter. So we get the answer, that is a 4.5 meter. So here rho is the density, that is equals to 1000. The G we have taken as a 10, rounding off. Area is a 15 meter square, and the H cut lies at the distance of 4.5. So we have 4.5 into 15 into 10 into 1000. So we get the answer, that is the 675 into 10 to the power 3 Newton, or we can write as a 675 kilonewton. Now we have to locate the center of pressures. So center of pressure is indicated by the H star, and for the vertical case, We know the formula of H star is Ig divided by AH cut plus H cut. So the value of Ig, that is the 31.25 divided by area, that is a 15 into 4.5 plus H cut is 4.5, 4.962 meter. So this is the answers, means this answer is from the free surfaces. So from the age of this, so center of CG, suppose let's say this is the center of pressure point, that is a CP point. So the height of this CP point over here from the free surfaces that we get here, it is the H star, and that height we get, that is the 4.962. So in this way we are able to solve this simple numerical. So let's say just numerical number 2. So I'm taking the numerical number 2, which is in line with this case number 3, that is an inclined plane. So here it is given a rectangle plane, surface 2 meter wide and 3 meter height, is immersed in water. Its plan is making an angle 45 with the free surfaces of water. The upper edge of rectangular plate is 1.5 meter below the free surfaces. Calculate the positions of center of pressure. So first of all, we need to understand how the geometry is there. So geometry is like, suppose the height is 3 meter and width is 2 meter. So we just draw this line like this. So this is our rectangular plate. This is the 2 meter wide and 3 meter height. Now it is suppose it is immersed in water. So I'm taking this surface as a free surface. It is immersed, and plan of this is making an angle with a free surfaces. That angle is a 45 degree. So here our plate is located like this. This is our plate, and here the CG point is there, which indicate with the G. And suppose let's assume this is the point where the center of pressure is acting. So P is there, and the force F, total pressure force, is acting over here. And if I'm taking the projections of this, then I get the plate like this. It is the plate, and this is the axis. If I'm taking the projection, see, this is our CG and this is our CP. I'm giving the name. This point is A point, this point is the B point. Similarly here A point is there, this is the B, this is the G point, and here it is the P or CP point is there. And this dimension is a 3 meter, and this dimensions is a 2 meter. And it is also say that the A point is having a depth of 1.5 meter. This H, it is 1.5 meter. Now first we take this CG point is indicated by the H cut, and this CP point is indicated by this H star. Figure is very important. How to analyze the cases is very important. So first of all, now we will write it down the given data. So first we calculate the area, that is 3 into 2, which is make a 6 meter square. Then we calculate this H cut. H cut is very important. So H cut is like, suppose this is simple and G point is located over here, which is at 1.5. So again we need to use the relation. See, this is our y distance and this is our h distance, and this angle is a theta. So we know that h equals to y into sine theta. So our h distance is becomes, this is a 1.5, and we need to add this. So here we need to take a one projection. Let's say this is the A point and this is the G point. I again represent over here. See, 1.5 meter, this is a 1.5 meter. Our A point is there and G point is there. So we need to take this height, this height. So 1.5 plus we have to add this, and this is becomes a ag sine theta. This is our g point, so it becomes ag sine theta, a into g into sine theta, and sine theta is having a value of 45 degree. So sine 45 is there, so 1.5 plus ag is also having a answer of 1.5, 3 by 2 into sine 45. So our answer is comes 2.56 meter. And again we calculate these ig is also necessary. So here our axis is like this, parallel to this reference axis. So perpendicular dimension is 3. So we get BD cube by 12. So here we get 2 into 3 to the power 3 divided by 12. And our answer is comes 4.5 meter to the power 4. First we calculate the total pressure forces, and then we calculate the center of pressures. So total pressure force is indicated by F, which is equals to rho g into a h cut. So rho is water, so 1000. G we are taking a 10. Area is a 6 meter square into h cut is a 2.56. So our answer come that is 150.72 kilonewton. And second is center of pressure, and this is the inclined case. So we know that h star equals to ig into sine square theta upon a h cut plus h cut. So we get ig, that is a 4.5 into sine 45 to the power 2 divided by area, that is a 6, into the h cut, that is a 2.56, plus the answer is a 2.56. So our final answer will come, that is a 2.707 meter from the free surfaces. So in this way we solve this numerical. We are taking some complex geometry, that is the equilateral triangle. So the numerical number 3 is the question 3. An equilateral triangle plant having the 2.5 meter side is immersed in the water with a base coinciding with the free surfaces. Means the surface of free surface as well as the upper surface of the plate is same, it is lies as a same height. Calculate the total forces and the center of pressure if the plate is vertical, and second, an angle of inclination of the plate with the free surface is a 60 degree. So here we have to solve the two different numerical, or we have the two cases in the same numerical. So first case the plate is vertical, in second case we need to go with the angle of inclinations with the free surfaces of the plate is 60 degree. So we have to solve the two cases. So just I'm writing down the first, that is a case 1, and I have taken the figure over here. So it is like that. The equilateral triangle is there, so the height as well as this is a 2 point, every side is a 2.5 meter, and we need to look at this, the center of gravity as well as center of pressure. This is center of pressure, this is center of gravity. So first of all we need to calculate the height of this triangle. So height we can calculate using the formula. See, this is a 2.5, and it is a 2.5 divided by 2 because the half triangle is over here. So we calculate first this h, and from that we can able to calculate this h cut, because the CG is lies from the base at a distance of h by 3. So using the Pythagoras we find it out the height of this equilateral triangle, which is the square root of the 2.5 to the power square 2 minus 2.5 divided by 2 whole to the power 2. So in this way we get this h. So we get the height, that is a 2.165 meter, and this h cut which is equals to h by 3. So we get the h cut equals to h by 3 for case 1, and that is the 2.165 divided by 3, we get 0.72 meter. And the area of this plate is 1 by 2 base into height. So base is a 2.5 and height is the 2.165. So we get 1/2 into the base, that is a 2.5, and height we have calculated, that is a 2.165. So our area we get, that is a 2.706 meter square. So now we calculate the total pressure force for case 1, which is indicated by F. So F equals to rho G A H cut. So water is there 1000, G we take the 10, area that is a 2.706 into H cut, that is 0.72. So our answer comes, that is a 19.11 kilonewton. Now we calculate the center of pressure, which is indicated by H star. So here the vertical case is that, so the formula of H star for the vertical plate or the vertical surface is Ig upon AH cut plus H cut. So we need to calculate the Ig for the triangle. So Ig equals to BH cube divided by 36. So the base is 2.5 and the height is 2.16 to the power 3 divided by 36. So our answer for the Ig is 0.7047 meter to the power 4. So we will put it down the value over here of Ig, that is 0.7047 divided by area, that is a 2. The area of this triangle is 2.706 into H cut 0.72 plus this H cut is 0.72. So the answer of H star we get 1.082 meter. Student, we analyze the first case. Now we have to go for the case number 2, in which the same plate is making an angle with the free surfaces, that is a 60 degree. Now we go for the case number 2 case. So we first making a geometry as well as positions of the plate. So this is a free surface, and here suppose I have this angle is 60 degree. So our plane is lies like this. So the free surface is, now I'm developing the perpendicular axis is that, and the height of triangle I have get this. So in this way the plate is located, and the center of gravity, which is G, and the center of pressure, it is P. This is the base is of 2.5, as well as this side is also 2.5, and the height is 2.16 we get. Now we need to take a projection of this G over here and P is here. So this distance from the free surface is H cut, and the distance of this is a H star. So first we calculate the H cut. So H cut equals to the Y cut into the sine theta. And we know that the distance, this A, suppose we say this is A point and G point, we know that it is 0.72 as we have already calculated in case 1. So this distance Y cut is 0.72 and this angle is 60 degree. So sine 60 is that, and we get this H cut, which is equals to 0.623 meter. So total force is, total pressure force for the case number 2, that F, which is equals to rho G AH cut. But now we have to take the value of H cut, that is 0.623. So 1000 is density of water, G is 10, The area we already have calculated in first case, that is a 2.706 into the h cut 0.623. So we get the answer of force, that is 16.53 kilonewton, and the center of pressure, it is h star, which is equals to Ig into sine square theta upon a h cut plus h cut. So the value of Ig is remains the same as we have calculated in first case, that is a 0.7047 into the value of theta is 60, so sine 60 to the power 2 is there. Area of this equilateral triangle is 2.706 into h cut, that is 0.623, so plus 0.623. So we get the answer of h star, that is 0.936 meter. So this is our answer for the total pressure as well as the center of pressures in case number 2. So now we are going to solve one numerical which is important, and it is the related with this case number 3, that is the inclined plane. But here in this numerical, the angle of inclination is not given directly, so we need to calculate the angle of this inclination, and that's why it is important numerical, and in university examination it is asked for 2-3 times. So let's start with this numerical. A circular lamina 125 centimeter in diameter is immersed in a water so that the distance of its edge measured vertically below the free surfaces varies from 60 centimeters to 150 centimeters. Find the total pressures force due to water on one side of the lamina and the vertical distance of center of pressures below the water surfaces. So first of all, by plotting down the diagram, we understand what is the situation is given in the numerical. So let's say I'm taking this is a free surface, and I just imagine one line, that is a theta, but it is given over here that, let's say, suppose this is the point A and this is the point B of my lamina. This is the lamina is that I just take the projections of for the side view, so I get this the circle over here. So let's say this is one circle is that this kind of lamina is that, and the distance from the free surfaces of this point is given, that is the 60 centimeter, and this A from the free surface is this A, that is 150 centimeter, and we know that the diameter of this plate is 125 centimeter. So suppose let I'm plotting one diagram over here which is show, suppose this point I'm taking, this is my C point, so here the B point is that, and at certain downward directions this A point is there, and we know that this AB is having the answers of this 125 centimeters, that is a diagonal of the surfaces, and from the free surface this height of the B point is 60 and this height is of 150. So here the height is 150, here the height is 60, so the distance between these 2 points is 90 centimeter, and we need to calculate this angle. So we are applying the formula of sine in this triangle. So we are applying the sine theta in the triangle ABC. In triangle ABC we have, and we calculate the sine theta. So it becomes the AC divided by AB. AC divided by AB. And AC means the sine theta is having the AC means 150 minus 60. So we get a 90. and AB means we have this diameter of the circle, that is 125. So we get the answers of 0.72. If we do the inverse of sine for this value 72, we get the theta, that is 46.05. Now this is the center, so it is a mid of the diameter. So we can calculate first the h cut. H cut is equals to the h1, that is the height of this point B, plus C point is a mid of this AB. So it is exactly divided this AB into two parts, and if you take a projections of this point over here, then it is also divide this AC into two parts. So we will write it down, this AC divided by 2. So H1 is our 60, and this is the value of AC is 90 divided by 2. So we get the 1.05 meter. So now the total pressure force. Before calculations of total pressure force, we just calculate the two quantity that we required, the area, which is equals to pi by 4 d to the power 2. So we get pi by 4 into a 1.25 or 125 centimeter. Directly we will write it down, 125 centimeter to the power 2. So we get the area, that is 1.22 meter square. We also calculate the value of Ig. Ig equals to pi by 64 d to the power 4. So we get 1.25 to the power 4 into pi divided by 64. So we get the Ig value, that is 0.119 meters to the power 4. So total pressure force, which is indicated by F. So we get F equals to rho G A H cut. So water, the density is 1000, G is 10, area we have calculated, that is 1.22, and H cut, that is 1.05. So our final answer for this total pressure force is 1264 0.61 Newton. And the center of pressure, which is H star, for the inclined case we know the value of H star equals to Ig into sine square theta upon AH cut plus H cut. So we get Ig is having a value of 0.11 into sine 46.05 whole to the power 2 divided by the area 1.22 into the height of the center of gravity, that is 1.05 plus 1.05. So finally we get the answer of H star, that is the height of center of pressure, that is 1.098 meter. So this is our final answer. So thank you students for attending this lecture. Thank you.